Okay, welcome to this video where we're going to be having a look through some of the topics that have not yet appeared from papers 1 and 2. Now you can see on the screen that I have ticked off some of the topics that we're going to be having a look at, but of course it'd be impossible to get through all of them in just a short video. Now my last posted videos I did actually go through one type of question on everything that hasn't appeared, but this is going to be slightly different in more of an exam style format. So we've got a lot to get through, so we better get started. Okay, so as with all of these videos, you can access the paper via the link in the description. You can get this downloaded and you can scan the QR code on the front that will bring you straight back to this video whenever you need it. So getting started with question 1. Now it says here, write the following numbers in order of size and start with the smallest number. So we want to find the numbers that are in the tens. Looking at these ones to start with, we've got numbers in the tens, hundreds and thousands. So we've got 35 and 53. 35 is the smallest, then 53, then we can move on to the number in the hundreds. You've got 340 and 540, so 340 goes first, then 540, and then we have the number in the thousands, so 3050. Hopefully a nice question to get started with. For the next one, we are collecting like terms. We've got 1y plus 1y plus another y and plus another y. Now don't forget the numbers in front of those, if they were written, would be 1, so 1 plus 1 plus 1 plus 1 would be 4, and they were in terms of y. So we have 4 y's in total. Not to be confused with when you are multiplying them together, which would increase the power. So if all those symbols were multiplication symbols, then instead our answer would be y to the power of 4. Of course they weren't, so our answer is 4y. For the next question, write 3/4 as a percentage. Now of course this is practice for a calculator paper, so don't forget you can always type that into your calculator and it will give you the decimal version. That decimal is 0.75. As a percentage, that is 75%. Remember you can turn a decimal into a percentage by multiplying by 100. So you can always write that down, because you never know what fraction's going to come up. That one there, you might have known it was 75%, but if you don't, there's a method for you. For the next question, how many minutes are in 2.5 hours? Well, in every 1 hour, there are 60 minutes. So in the first hour, we'd have 60. In the second hour, we'd have another 60. And then we'd also have half an hour, which is half of 60, or 30 minutes. If we add those all together, and again, don't forget you have a calculator for this, but 6, 12, 13, 14, 15, that adds up to 150. So 150 minutes in 2.5 hours. Find the number that is exactly halfway between 20 and 36. There's a couple of ways that you could do this. As we have a calculator, I like the method of adding them both together, which would give us 56, and then dividing that by 2. So 56, when you add them together, divided by 2, gives us 28. So 28 is in the middle of 20 and 36. And that makes sense because 28 is 8 away from 20, and 8 away from 36. So there we go. On to the next question, we have some combinations. So it says Karen is going to have a meal. She can choose one starter and one main course from the menu. Write down all the possible combinations Karen can choose. Now when doing these, it is okay to use the letter at the start. So when I'm writing salad for the starter, I'm also going to write P for pasta. So SP is absolutely fine for salad and pasta. I actually need to combine the salad with all the other mains, so I may as well just stick to salad. So salad and rice, and I can also have salad with a burger. I'm going to follow that same approach, but just working through the starters. So I'm done with salad. I can now do fish with pasta, fish with rice, and fish with a burger. And then cross that one off. Take note of the way that I'm doing this because you don't want to miss out any of these combinations, and if you do them in a random order, it's quite likely that you're going to miss one. So I'll move on to the melon. We have melon and pasta, melon and rice, and also melon with a burger. And there we go, there's all my combinations. On to question 7. Connor sells CDs in a shop. The tally chart shows information about the number of CDs Connor sold on Monday, on Tuesday and on Wednesday. Write down one thing that's wrong with the tally chart. Well, other than drawing the tally incorrectly, the only other thing that you could do wrong is count up the tally incorrectly. So if we have a look and see if they've been counted correctly. So on Monday we have 5, 5 and 3, and that adds up to 13. Now straight away 12's written in the top, but it should be 13. So we just write that. So Monday should be 13. There we go. And if you're not sure how to explain something, that one's relatively nice and easy. You can always point an arrow from your description and just point it at the one that you're talking about, if that helps you with your explanation. For the next one, it says Connor drew this pictogram to show the information for Tuesday and Wednesday. Write down one thing that is wrong with this pictogram. Well, it is linked to the tally chart above, so it could be that they don't match the numbers above, and that would be fine if that's the case. But something that stands out to me is the key is a very strange one. So in this key, it's kind of a circle that's split in half, and that says that it represents 3 CDs. Now that would mean something like this, where we have half of a circle, would be half of 3. And half of 3 is 1.5. So that there represents 1.5 CDs. And obviously we know we can't have 1.5 CDs. CDs don't come in halves. So in terms of one thing that's wrong with the pictogram, you would have, and I'm going to point to the key here and say you can't have, let's write that again, you can't have 1.5 CDs. And there we go, we've got our arrow pointing to the key that shows what we're talking about. So there we go, there was analysing a pictogram. For the next one, we have in Kian's garden, the flowers are only red, white, yellow or blue. The chart shows the number of red, white and yellow flowers. It did say that there was blue as well, so that's not shown on the chart. It says the total number of flowers is 32, work out the number of blue flowers. So if we read from the chart, we have 8 red, which you can see by just tracing along to here. So 8 red, we've got 10 white, and we've got 5 yellow. And careful with that one because that one does fall in between the 4 and the 6, so just make sure you read the scales carefully. If we add those together, 8 plus 10 is 18, plus the 5 is 23. So the ones that are missing have to be blue. So if we do 32, the total amount of flowers, take away what we already know we have, 23, we end up with 9 that are left over. So there must be 9 blue flowers. It then says write down the number of red and yellow flowers. So looking at what we have, red and yellow flowers, red was 8, yellow was 5, so in total that is 13. So 8 plus 5, if I write down my working out, that's equal to 13. And there we go, there was just reading some information from the line graph. Question 9. Maisie carries out a survey of 240 people for dietary requirements at an event. 50% of the people say they eat meat, 35% of the people say they are vegetarian, the rest of the people say they are vegan. Work out the total number of people who say they are vegan. Well, we could either work out these separately, so I could work out the 50% and the 35%, or I can think of that as a total percentage. Now 50 plus 35 is 85%. And that means the rest of the people that are vegan would be 15% of the people, as they've got to add up to 100%. So now we've got the percentage that are vegan, we just have to work out 15% of 240. So 10%, and you can do this on your calculator, you can just divide that by 10, would be 24. Remember, this is 240 people in total. 5%, which is half of that, would be 12 people. And in total, that adds up to 36. So there are 36 people in total that are vegan, and that would be our final answer. Of course, we could have worked out 50% of the people, which would have been 120. We could have also worked out the 35%, but by the time we get to working out the 35%, we've already done more work than had we have just worked out 15% in the first place. So I think I prefer that method where we can use it. On to question 10, we have some substitution. So it says t is equal to 3x's take away 4y's. Work out the value of t when x equals 9 and y equals 5. Now when you're substituting numbers in, we're going to sub it into this expression on the right. So you have 3 x's and x is 9. So you have 3 times 9, and we need to take away 4 of the y's. Y is equal to 5, so 4 times 5. We're going to work out these multiplication parts first. So 3 times 9 is 27, 4 times 5 is 20, and we're taking those away from each other. So 27 take away 20 is equal to 7, so our answer would be 7. For part B, it says work out the value of x when t equals 38 and y equals 7. So if we're going to sub this into our sort of formula up there, we've got t is 38, which would be at the start. That's going to be equal to 3x, and then take away 4 lots of 7. Now 4 lots of 7, if we work this out to the side, would be 28. So we have 3x minus 28. So essentially in this question we have to solve an equation. To do that we would need to add 28 to both sides, and 38 plus 28, we can always do this on the calculator, it's not an awful one to do, but in this moment in the exam we definitely just want to put it in the calculator without having to think about it. That comes out as 66. So 66 is equal to 3x. To find the value of 1x we would want to divide by 3, and 66 divided by 3 is 22. So 22 is equal to x, and we could say that the value of x therefore is 22. And there we go, there's our substitution. Okay, so on to question 11, we've got some solving equations. So for part A here, we have t plus t plus t is equal to 45. Well, that's 3 t's, which are equal to 45, and if we divide by 3, we get t is equal to 15. So we have 15 for part A. For part B, we have p divided by 3 is equal to 12. When something's being divided by a number, like this is being divided by 3, we can reverse that by multiplying by 3. So p will be equal to 12 times 3, which is 36. So our answer is 36. For part C, we have unknowns on both sides. So here we want to delete or subtract the smallest unknown from either side. Now in this case, 3w is the smaller unknown, so we're going to subtract 3w from both sides of the equation. That would leave us with 2w take away 7 is equal to 10. We can now solve this like we normally would, adding 7 to both sides as we have a negative 7 there, which would give us 2w is equal to 17, and then dividing by 2, which would give us w is equal to 17 divided by 2, or you could type that into your calculator and get the answer 8.5. Either answer is fine, so I'm going to put 8.5 on the dotted line. Okay, so that was some solving equations, and for question 12 we have writing a ratio in the form n to 1. When we need to do this, you just need to divide the number in the place of the 1 by whatever that number is. So in this case it's 2.25. So we need to divide both of these numbers by 2.25. 4.5 divided by 2.25 on the calculator is equal to 2. And obviously 2.25 divided by 2.25 is 1. And that's the form we were trying to get it into. So our answer would be 2 to 1, and there we go. 1 mark for that one. For question 13, we are asked to draw a stem and leaf diagram. This is always quite awkward to draw, because especially when there's a lot of numbers. So for this one, have a look at the list. We have numbers in the 60s, all the way up to numbers in the 90s. So down the side of the stem and leaf, I want 60, 70, 80, and 90. And of course, I need a key to go with that, so that it makes sense. So 6 slash, and then any number, let's go with 3, is going to be equal to 63. And that would be my key for this stem and leaf. Now I can start putting the numbers in. So if I find ones as I go, I'll look for the smallest number in the 60s. So we have 64, then 67, so 4 and 7, and always leave yourself a bit of a gap between the numbers just in case you do miss one. Then we've also got 69 and 69. And that looks like all the 60s. Moving on to the 70s, we've got 2 that are exactly 70, so cross those off, and we've got 0, 0. We have 71. We've got 75. Looks like there are 2 76s, and there's a 77. And I can't see any more 70s. On to the 80s, we've got 80 exactly, and there's 2 of those. we've got 81, 82 and 84 on another 81. So 81, 1, 2 and 4, and then we've also got 87. That only leaves us with two numbers, 91 and 94. So 91 and 94. And there we go, there's our stem and leaf drawn. For part B, it says find the median score. Now this is going to be a bit of an awkward one because there's an even amount of students. So if we do a method where we cross off numbers either side, that's going to mess up our stem and leaf that we've drawn. So it might help if we just underline the numbers instead. Of course you can use a statistical method here and that's fine as well, but I'm just going to underline the numbers. So 1, 2, 3, 4, 5, 6, 7. I'm just going to do a few from either side. 1, 2, 3, 4, 5, 6, 7. Then I'm just going to go one by one, 1, 1, and I end up with these two numbers in the middle. And that would obviously make sense that there'd be two numbers in the middle when we have an even amount of numbers. So I want to know what's in between these two. They are the number 76 and 77. And in the middle of 76 and 77 is 76.5. So my median for this question will be 76.5, and that's that. If you're not sure what's in between the two, you can always add them together and divide it by 2, like we did at the start, and that will give you the midpoint of those two numbers. So there we go, there was using a stem and leaf. Okay, and moving on to some pie charts. So it says there are only silver, blue, red car parks at Allerton School and at Bragdon School. The pie charts show information about the numbers of these cars. What fraction of the cars in the car park at Allerton School are blue? Give your fraction in its simplest form. So if we look at Allerton School, which is the pie chart on the left, and we're looking at the blue cars. Now you can see this is the portion that's blue in the pie chart, and that's 150 degrees. We know the total in a pie chart adds up to 360. So any part of the pie chart is going to be out of 360. So this one here is going to be 150 out of 360. To simplify that, we can just type it in on the calculator. 150 on the top, 360 on the bottom, and it simplifies it for us down to 5/12. Of course, if you don't have a calculator that does fractions, you can type in 150 divided by 360, and it should give you the fraction in linear form. It says here there are 12 red cars in the car park at Bragdon School. How many silver cars are there in this car park? And you must show how to get your answer. So over at Bragdon School, now looking at the right, this here is going to be 12 cars. Now there's a few different ways that we could break this down, but we're ultimately looking at how many silver cars there are. So we're trying to find the amount of silver. Now when it comes to this, if that is 60 degrees, if we want to know the size of what 1 degree is, it's going to be a decimal amount of cars, but we could divide this by 60. That would tell us that 1 degree, if we divide by 60, 1 degree is going to be equal to 12 divided by 60, comes out as 0.2. Obviously we can't have 0.2 cars, but we also don't have 1 degree in the pie chart. For the silver cars, we have 210 degrees. So 210 degrees is going to be equal to whatever 0.2 is times by 210. So on the calculator, I'm just going to times by 210, and that gives me 42 cars. So for that one there, we have just broken it down. 60 degrees was 12 cars, so dividing by 60 told us that 1 degree was 0.2 cars. We wanted to get to 210 degrees, so just multiply by 210. So for this one here, our answer is just 42, and we've shown how we got our answer by our working out up there. For part C, it says, in which car park are there more silver cars? Tick one box to show your answer and explain your answer. Well, looking at these, we don't actually know how many cars there are in any part of the Allerton School. So we don't know how many red, blue or silver. So without any more information, we actually couldn't answer this question. We would need to know at least one of the cars in Allerton School to find out how many there were silver. But because we don't have any information about Allerton School, we just simply don't have enough information. So we'll tick this, not enough information. We don't know how many cars are at Allerton School. There we go, and that would be fine as our explanation. We don't know how many cars are at, And let's make sure we have a look at the name of the school, Allerton School. And there we go, and that's our answer. So because we don't have any more information, we can't make any assumptions based on the size of the sector that's within the pie chart. You can obviously see that the sector is bigger at Bragdon School, but we don't know how many cars there are at Allerton School, so there actually could be more. Looking at question 15. Okay, so for this one we are estimating the mean from a table, and it wants our answer correct to 3 significant figures. Now when we're estimating the mean from a table, we just need to multiply across to get the total for each row. But when we're estimating from a group like this, we have to use the midpoints. So the midpoint of 5 and 10 is 7.5. The midpoint of 10 and 15 is 12.5. The midpoint of 15 and 20 is 17.5, and the midpoint of 20 and 25 is 22.5. We just need to do these on the calculator. So we'll work out all 4 of these. So 1 times 7.5 is 7.5. 2 times 12.5 is 25. 17.5 times 7 comes out as 122.5. And 8 times 22.5 comes out as 180. If we add these together, we'll have the total. So 180 plus 122.5 plus 25 plus 7.5, and that comes out as 335. So this was about the time taken in seconds by 18 students to run a race. So we know the total of the frequency is 18. The total estimated time for those 18 students is 335. So to estimate the mean, we'd do 335, divide it by the 18 students, and if we just type that in on the calculator, we get 18.61, and it's a recurring one, so that just keeps on going. It only wants our answer correct to 3 significant figures, so if we go 186, chop it after that 3rd significant figure, it's a 1 after the line, so it just stays as 18.6, and that's our final answer. So 18.6 seconds is our estimated mean. On to question 16. It says Zidane invests £800 for 5 years in a savings account. The account pays simple interest at a rate of 3.5% per year. Work out the total amount of interest Zidane gets. So we're not looking for how much money he has in his bank account, we're looking for the total amount of interest. And this is going to be paid in simple interest. So with simple interest, different to compound interest, we get the same amount every year. So we just need to work out 3.5% of 800, and he'll get that every year for 5 years. So working out 1%, if we divide by 100, we get £8. We can also get 0.5%, which is going to be half of 8, or £4. And we can then build this up to 3.5. Of course, if you're using your calculator, which we are, once you've got 1%, you can just multiply that by 3.5. But I actually don't think this is too difficult to do without a calculator. We just want 3 of those and 1 of the 0.5s. I'm just going to do 8 times 3.5 on my calculator just to be quicker on this, but 3.5% is going to be equal to 28. Now it says he's going to have that for 5 years, so if he's having it for 5 years, we're going to multiply that by 5, again on the calculator, and that comes out as £140. So the total amount of interest he's going to get is £140, and that would be our answer. If it said how much does Zidane have in his bank at the end of 5 years, we'd say £940. We'd just add that on to the £800 that he already had in there. And there we go, that is simple interest. On to question 17. It says on the grid below, draw the graph of y equals 1 minus 3x for values of x from negative 3 to 3. And it's given us a blank space here, and this is to draw a table. So we have x and y. X, it says it wants to go from negative 3 to 3. So negative 3, negative 2, negative 1, 0, 1, 2 and 3. Draw in our table, and then we just need to find our value of y. Now depending on which calculator you have, at this point you could use the table method. So in your calculator, if you are using a Casio, you can press menu 3 and then you can type this equation into your calculator, put the starting number as negative 3, the end number as positive 3, put your steps as going up in 1, press equals, and it will give you all these numbers. If you don't have that calculator, then you're going to have to substitute these numbers in. So I'd start from the right hand side. You've got to be very careful with this one, but it says y is equal to 1 take away 3x. So that'd be 1 take away whatever 3 times x is, and this is 3 times 3. So if I was to write the 3x just above, 3 times 3 is 9. So it's 1 take away 9, which is negative 8. 3 lots of 2 is 6. So for this one next to it, it's 1 take away 6, which is negative 5. Now I only need to do a couple because now I can spot the pattern. So going backwards this way, we are adding 3 each time. So adding 3 to negative 5 is negative 2, add 3 again is 1, and then 4, and then 7, and then 10. So it's pretty quick to do this table even if you don't have table mode. Plotting these coordinates, we just need to plot them very carefully. So negative 3 up to 10 would be just here. Negative 2 to 7 would be just here. Negative 1 to 4 is just here. And even at this point you can start to spot a bit of a pattern. Each point goes down 3 squares, right 2 squares. So I can just follow that pattern going down and across, down and across, down and across, and same again for that one, and that finishes on the x equals 3. So I've drawn in all my points. I just need to join these up, making sure I use a ruler and a pencil and I don't miss any of the points, and of course it should form a perfect straight line. So if any of the points are not creating a straight line, you know that you've got one of the points wrong in your table, and you need to go back and correct the numbers in your table to ensure that it does make a straight line. And there we go. On to our next one. Okay, so for this question we have exchange rates and we have best value. It says in France, Chloe pays €27 for 18 litres of petrol. In Wales, Arjun pays £40.80 for 8 gallons of the same type of petrol. €1 is equal to 85 pence, and 7.5 litres is equal to 1 gallon. Chloe thinks that petrol is cheaper in France than in Wales. Is Chloe correct? And you must show how you get your answer. Now these questions can seem very confusing, but when we are looking at best value, we just need everything in the same units. So if we have a look at this question, let's get everything into pounds and everything into litres. So the first one is already in litres, but we need to turn this €27 into pounds. Now this exchange rate, we've been given the €1 is equal to 0.85. So we know that the pounds number is going to be smaller. So to make this number smaller, we would have to multiply by 0.85. If we divide by 0.85, the number gets bigger and it doesn't make sense in our exchange rate. So 27 multiplied by 0.85, and we can type that in on the calculator, and that comes out as 22.95. That is now in pounds. So in France, it's £22.95 for 18 litres. So that's in the form that we want it. For the second one, it's currently in pounds, but it's written in gallons. So if we look at our gallons exchange rate, 1 gallon is 4.5 litres. So to turn this into litres, the litres number is going to be bigger, so we're going to multiply by 4.5. So 8 times 4.5, that gives us 36. So that's going to be 36 litres. So we now actually have something that we can do the best value of. We've got everything into pounds, we've got everything into litres. So if I write these two options down below, we've got 18 litres, and that costs £22.95. We also have 36 litres, and that is going to cost £40.80. So these are the two options that we have. So on the left, that was 18 litres for £22.95, and that was in France. And on the right, we've got the 36 litres for £40.80, and that is in Wales. So at this point, we've done our exchange rates. We actually now just need to do our best value process. So when we're looking at best value, we want to get the cost of 1 litre. So on the left, that's 18 litres, so we would divide this by 18. And on the right, that's 36 litres, so we divide this by 36. £22.95 divided by 18 comes out as £1 and then 275. So about £1.27, £1.28. On the right, £40.80 divided by 36, that comes out as 1.13, and it is a recurring 3. So pretty much £1.13. So looking at which is best value, you can obviously see that £1.13 per litre is cheaper than £1.27 or 28p. So it's cheaper in Wales. So here I'm just going to write Wales is cheaper. And I just need to make sure that I actually answer the question. Chloe thinks that petrol is cheaper in France than in Wales. Is Chloe correct? You must show how you get your answer. So Wales is cheaper. Chloe said that she thought it was cheaper in France. So we would say Wales is cheaper. Chloe is incorrect. And there we go, there's our final answer. So not a very nice question there, but of course you just need to make sure everything is in the same units and then apply your best value method. Quite a tricky one though. So question 19. Expanding and simplifying, and we have two sets of single brackets. So start with the bracket on the left. 5 times x is 5x. 5 times 2 is 10, with a plus symbol in between. We are then going to add to that 3 times 2x, which is 6x, and 3 times negative 1, which is negative 3. We can now just collect like terms. So we have 5x plus 6x, in total that's 11x, and we have plus 10, take away 3, which in total is plus 7. So 11x plus 7 is our final answer. For the next question, we are simplifying with indices. When we are multiplying, we add powers, but any numbers at the front are just going to be multiplied like normal numbers. So we have 4 multiplied by 5, which is 20. And then looking at our x's, we have an x to the power of 1, remember the 1 is not written, and an x to the power of 3. Adding those powers gives us x to the power of 4. For the y's, we have y to the power of 2 and y to the power of 5. Adding those together, that gives us y to the power of 7. And there we go, that's our final answer. On to question 20. So in this question, we can already see there are some parallel lines. It says A, B, C and D, E, F are parallel lines, which we can see via these arrows. It says work out the size of angle X. Give a reason for each stage of your working. So angle X is just here within the triangle. So we know angles in a triangle add up to 180, so if we can find this angle and the other angle in the triangle, we'll be able to subtract them both from 180. That angle that I've highlighted looks like a nice easy one to start with because we have 3 angles there that are on a straight line. Remember when it makes this sort of semicircle here around this particular point, they add up to 180. So you've got 110 and 125. If we add those together, they add up to 135. So if we take that away from 180, we know that the missing angle there is 45 degrees. So this is going to be 45. And it does say give a reason for each stage of your working. So I'd want to write next to that, angles on a straight line add up to 180 degrees. There we go. Add up to 180 degrees. And you can always point that to the working out that you've just done. Now the next part of this is a little bit trickier because we have got to apply some of our parallel line rules. Now unfortunately, where G is, it doesn't extend all the way down to the next parallel line, so we can't apply anything on that side. But on this left hand side we do have a line which is extending between the two, and that's the line going from B to E. Now we can use that to find an alternate or a corresponding angle, potentially from top to bottom. Now it's up to you which way you go. We could go this way and hook it around this side, and we know that this angle here and this angle here are alternate angles, and alternate angles are equal. You could also do that on the other side and work your way around that way, but now I've highlighted that, I'm just going to go for this one. So if those two angles are 110, and here we have actually got part of the angle, that's the 35. So I'm going to have to do 110, take away the 35, and that'll tell me what's missing. So 110, take away 35, and obviously don't forget you've got your calculator, that adds up to 75 degrees. The reason for that was because alternate angles are equal. There we go, alternate angles are equal. And of course you might be looking at this question and thinking about a different route, and that's absolutely fine as well. But there we go, that one is 75 degrees. I can now find the value of x because angles in a triangle add up to 180 degrees. So I can finish this off, 75 plus 45, and that adds up to 120. Angles in a triangle add up to 180, so 180 minus 120 is going to be equal to 60 degrees, and my reason for that, angles in a triangle add up to 180 degrees. There we go. And the important one there that we needed to make sure that we mentioned was that alternate angles are equal. And there we go, and it creates that almost backwards Z shape or a Z shape depending on how you draw it. So there we go, there is some angles in parallel lines, and on to our next question. So question 21 says find the lowest common multiple of 40 and 56. Now if we want to find the lowest common multiple, particularly if we have a calculator, we just need to write down some of the multiples, or in other words, their times tables. You have a calculator for this, so it makes sense to start with the number that isn't as nice, because here, because we have 40 as one of them, we know that any multiple has to end in a 0. So if I just go on my calculator, 56 plus 56, that gives me 112. And then I just want to keep adding 56. So if I press equals, I get 168. And I can just keep going, 224, 280, and that ends in a 0. So I can then do some of the 40s, 40, 80, 120, 160, 200, and at this point I've spotted it's definitely going to become 280. So there we go, we found our lowest common multiple, it was 280. Sometimes you do have to go for quite a distance, but just don't give up on it and keep going along your table. But 280 is the lowest common multiple of these two. For part B, we're given some numbers, but we're giving them, they've been written for us almost like a product of prime factors. It has been written as a product of prime factors. But we can type these numbers into the calculator. So 2 cubed multiplied by 3 multiplied by 5, that's the number 120. Likewise, 2 squared times 3 times 5 squared, that comes out as 300. And it's not actually awful to find the highest common factor of those numbers. You might already spot that the answer is 60. It's quite a nice one to actually have a go at. So the answer for this is 60, but there are a couple of ways that you could go about finding that. Once you've written it as whole numbers, you could write it out as 120 and 300 and find the factors of each number. 1 times 120, 2 times 60, and at this point you might have just spotted 60 goes into 300. So that's one way that you could do it. You can also use the matching up method. So here in each number there is a 2 to the power of 2. Obviously in A there's a 2 to the power of 3, but they share a 2 to the power of 2. They also both have a 3 and they both have a 5. To find the highest common factor, you just multiply those together. So I'll do that on the calculator. 2 squared times 3 times 5 is 60. And there we go, that'll give you the highest common factor as well. So lots of different methods you can use when there's a question like that, but of course it is only a 1 mark one, so it's meant to be quite a quick one. On to question 22. Here is a 4-sided spinner and it gives us the table. So it shows the probability of landing on each number. Work out the probability the spinner will land on a 2. Well, these numbers here have to add up to 1. So if we add them up, at the moment they add up to 0.7. So 1 take away 0.7 is equal to 0.3. So our missing number from the table is 0.3. It does want it on the dotted line here, so we'll put it there. It says Jake is going to spin the spinner 60 times. Work out an estimate for the number of times the spinner will land on 1. Well, if we look at the probability of 1, that is actually a probability of 20%. So there's two different ways that you could work this out. You could either just work out 20% of 60, which wouldn't take you too long. 10% is equal to 6, so 20% will be double that, it'll be equal to 12. So our answer is 12. You could actually just take the decimal 0.2 and multiply it by 60, and that will also give you 12. So two different methods again that you could use to work that out. On to question 23. So for this one we have a double bracket to expand. So we've got 4 multiplications to do. 5x times 2x gives us 10x squared. 5x times negative 3 gives us negative 15x. 2 times 2x is 4x. And 2 times negative 3 is negative 6. We can then combine these two in the middle, and that leaves us with 10x squared, negative 15x add 4x is negative 11x, and then we have negative 6 at the end. So our final answer is 10x squared minus 11x minus 6. For part B, we're asked to factorise a quadratic. When factorising a quadratic, you need to recognise that they go into double brackets. They both start with an x. We just need to find the factor pairs that multiply to make this number at the end. So that can only be 1 and 3. So that would be x plus 1, because we're trying to make plus 4 in the middle, and x plus 3. So that would be our final answer, x plus 1 and x plus 3. It's important to note at this point you could be asked to solve one of these. If it did say to solve, it would be equal to 0, and if you were solving like that, you just flip the symbols of the number in the bracket. So for this one, x would be equal to negative 1, and for this one, x would be equal to negative 3. But even when you are asked to solve, you get the most of the marks for just factorising it. So make sure you're happy with factorising. On to question 24. Okay, so for this question we've got some conversions to start with. So it says to write this number in standard form. Now we need it between 1 and 10, so we want the decimal to go between the 7 and the 5. So if we write those first numbers out, we will have 7.547, and in standard form it will be times 10 to the power of something. So if we count the jumps to get there, 1, 2, 3, 4, 5, and because it's a 0 point number, it'll be negative 5. So there we go, that's converting it in standard form. For part B, we have a slightly larger thing to work out. Now this can just be typed into the calculator. So if I press the fraction button, and then type in what I have on the top and what I have on the bottom, and it will just straight away give me the answer. Of course, for a question like this, you could actually work out what's on the top, write that number down, and then divide it by what's on the bottom, particularly if you don't have a scientific calculator that allows you to press the fraction button. So if I type this on the top, I'm just going to type in my brackets, 2.3 times 10 to the power of 4, multiplied by 6.7 times 10 to the power of 3, and on the bottom, 5 times 10 to the power of negative 8. And we get 3.082 times 10 to the power of 15. So there we go, that would be our final answer, 3.082 multiplied by 10 to the power of 15. Okay, and on to our next question. Okay, so it says ABCD is a trapezium. Work out the length of AB. So AB is this kind of like diagonal line just here. It says give your answer correct to 1 decimal place. Now with any shape like this, don't forget you can always create right angled triangles. So if I cut a line across the top, it creates a kind of rectangle with a right angled triangle sitting on top of it. Now the base of that triangle is the same as the base of the rectangle. That's going to be 5 meters. For the actual height of that part of the triangle, we're going to have to work out the difference between the two heights. By that I mean A to D is 9.8 and B to C is 14.1. So to find that missing length just here, I can do 14.1, subtract the 9.8, that's going to tell me that missing length. I can type that in on the calculator, so 14.1 take away 9.8, and that gives me 4.3. So now to find that missing length, I can use Pythagoras theorem. I have a right angled triangle, I've got the height and I have the base, which are two of the shorter sides. So if I draw that over here, that's 4.3 and 5, and Pythagoras theorem is a squared plus b squared is equal to c squared. Or in other words, square the shorter sides, that will tell me c squared, or that missing length. I can square root my answer. So to work this out, I'm going to do 5 squared plus 4.3 squared, and again I'm just going to type that in on the calculator, so 5 squared plus 4.3 squared, and that comes out as 43.49. To get my final answer, I just need to square root that, as that's the value of c squared, and we just want to know the value of c. So doing that gives us 6.594 and a few more decimals. I'm not going to write it all down because it says it wants my answer correct to 1 decimal place. So if I cut it after the 5, which is the first decimal, there's a 9 after the line, so that rounds up to 6.6. It was asking for a length, this is all in meters, so that's going to be 6.6 meters. And there we go, that was applying some Pythagoras theorem. On to question 26. It says make x the subject of the formula. So for this one here, we have some brackets involved. We need to get rid of the brackets. So if I multiply those by 3, instead this would say y is equal to 6x minus 15. Now to make x the subject, it means it wants x on its own. So I first want to get rid of this minus 15 by adding 15 to both sides. So that's going to be y plus 15 is equal to 6x. We're close to getting it as x on its own, but to get rid of the 6, we're going to have to divide by 6. When I divide, when I'm rearranging formula, I don't want to write the divide symbol, I just want to put that everything on the left hand side is being divided by 6 by writing a fraction line. So 6 on the bottom, and that's now equal to 1x. X is now the subject. So there we go, I could write that the other way around. I could just say x is equal to y plus 15, all divided by 6. And there we go, that's changing the subject. For question 27, we have some shaded regions and we have a circle. It says here the diagram shows a rectangle, ABCD, and a circle. BC is the diameter of the circle. Calculate the percentage of the area of the rectangle that is shaded and give your answer correct to 1 decimal place. Well, there's something really quick and easy that we can work out here, and that's the area of the rectangle. So if I draw a rectangle, just so I can show exactly which shapes I am working out here, I've got 16 multiplied by 19. I'm going to type that in on the calculator. 16 times 19 is 304. This is in centimetres, so that's centimetre squared. To get the shaded region from the rectangle, I'd only really want to know the area of the semicircle. So I just want to work out the area of this semicircle just here. Now to work that out, I need to know the radius. Now the diameter is going to be the same as the 16. So if that's 16, the radius will be half of that, which will be 8. The formula for the area of a circle, area is equal to pi r squared. Of course, we only really want to look at the semicircle, so we will divide our answer by 2. But let's work out the area of the full circle. So for the circle, that's going to be pi multiplied by 8 squared. I'm just going to type it in on the calculator. Now that gives me an answer of 201.0619298. We want a semicircle, so I'm going to divide that by 2. So the semicircle that we're looking at is going to have an area, when we divide that by 2, of 100.5309649. I'm going to write them all down for the moment because I don't want it to affect my final answer. So if I want to know the area of that shaded region, I would take the area of the rectangle and subtract the area of this shaded region, or the unshaded region. And that's going to tell me the area of the actual shaded part. So if we take these away from one another, I'm going to do 304 subtract the 100.53 and the rest of those decimals. So on my calculator, it's going to do 304, take away the answer, and that gives me 203.4690351. Now that there is the shaded region. Now this question didn't just ask for the area of the shaded region. It says calculate the percentage of the area of the rectangle that is shaded. So the area that's shaded is this 203. The total rectangle though is 304. So we need to work out what is 203 out of 304 as a percentage. Now I'm going to start that by just writing it as I've said it. 203.469. Let's write those the right way. 469 out of 304. If I type that in as a fraction, if I just do that on the calculator, that gives me 0.669306. Now that has given me the decimal version. So to turn that into a percentage, I just want to multiply that by 100. So on the calculator, times my answer by 100, and it gives me the percentage, which has come out as 66.93060365%. The question has said give my answer to 1 decimal place. So if I chop it after the first decimal, after the line is a 3, so it's not going to change, it's going to be 66.9%. And there we go, that's going to be my final answer, so 66.9. And there we go, that is percentage of an amount, where we also had some shaded regions, including area of a circle. On to the next question. So this says complete the table of values for y equals x squared minus 2x plus 2. And of course, as we mentioned earlier with a question similar to this, you can use the table method. Now if you don't have the table method, then you're going to have to type each one individually. So this is going to be, and we're using the x number here of 4, I would have 4 squared, take away 2 times 4, and then add 2. Careful with this multiplication part, it's just safe to just put that in brackets so you remember the order you're doing it. But if I type that into the calculator, I get 4 squared, take away 2 times 4 in brackets, and then add 2 at the end. And that gives me the answer 10. I just need to repeat that, but swap the 4's, so this number here, and this number here, for the next numbers in the table. A good way to test that you're doing it correctly is to test it with 3, and we should get the answer 5. I'm going to go ahead and do that. So if I delete the 4's and exchange them for 3's, I've got 3 squared, take away 2 times 3, and then add 2, press equals, and I get the answer 5. So I know I'm doing it correctly. So now I need to swap the 3's for 2's, press equals again, and I get 2. Swap the 2's for 1's, press equals, I get the answer 1. I'm not going to test the 0 because I already know I've got that right. Now I'm going to put the negative 1 in. Now here's where I need to be really careful. So when we put a negative into the calculator, we should always put it in a bracket. And this only really matters if the number is being squared. But of course in this one it is being squared. So when I put the negative 1 in, I want the negative 1 in brackets squared, take away in brackets 2 times negative 1. Now that negative 1 is not being squared, so I don't need to worry about that one, but then plus 2. So when I'm exchanging the 1's for negative 1's right now, I am just going to have to put that negative 1 at the start in a bracket, press equals, and I get the answer 5. You can already see as well there is a bit of a pattern, so there's here 2 and 2 either side of 1, and then as well as that you've got 5 and 5, and then you can see 10 and 10. So there is a bit of a pattern as you're going through it, so you can kind of get away with not doing those negatives. But plotting the points here, we've got negative 2 that needs to be plotted on 10, and that's just there. We've got negative 1 to be plotted on 5, just here. 0 and 2, 1 and 1, 2 and 2, 3 and 5, and 4 and 10. And there you go, you can see it makes this U shape. Now when you're drawing this graph, you do need to draw it up with a nice smooth curve. So I tend to just do one side at a time, because you need to make sure you also don't miss any of the points. Obviously you need to do this with a ruler and a pencil, so join them up really carefully, making sure you draw a nice smooth curve, and there we go. So there we are, it makes this nice U shape. Now a lot of the time when you're drawing these, it does actually cross through the x-axis, but this one is just slightly above, so it doesn't have any roots where y is equal to 0. But it does ask us a part C question. It says use your graph to find estimates of the solutions of the equation x squared minus 2x plus 2 where it's equal to 4. That's a little bit different to some of the questions that usually come up. Normally it says equal to 0. Now if it was equal to 0, if the graph did cross through the x-axis, obviously this one doesn't, but let's imagine it did. And if it did, you would read the x values of the two places where it crosses through. Or of course maybe it would just cross through at one place if it was sitting on the x-axis. Now this one doesn't, and that's why they've asked us to find it where it equals 4. So when we're doing that, instead of y equals 0, which is called the x-axis, we're going to draw the line y equals 4. And if we draw the line y equals 4 going across, it's asking us for the x values where these two lines intersect. So I just need to read those very carefully. So if I trace down to the x-axis, I've got one there, that looks like negative 0.7, and I've got another one just over here, and that is 2.7, and they're my two solutions. So where the lines cross, I've got one solution where x is equal to 2.7, and I have another one where x is equal to negative 0.7. And there we go, that's finding solutions when it's not equal to 0 just there, just drawing a line through whichever line it's asking us to. So in this case, it was y equals 4. Okay, on to our next one. Each exterior angle of a regular polygon is 15 degrees. Work out the number of sides the polygon has. Now when it comes to exterior angles, an exterior angle of a polygon, if we kind of imagine that we kind of had one drawn, let's just imagine we had some sort of pentagon sort of shape drawn over here. This on the inside of the pentagon is the interior angle. We're looking at the exterior angle. So this one just here is the exterior. And there's a few rules that come along with this. So the exterior angles and the interior angle together adds up to 180 degrees. But the exterior angles going all the way around a shape form a full turn. So all of them added together will equal 360. So if we know one of the angles is 15 degrees and we do 360 divided by 15, it's going to tell us just how many of those angles there are. There's one for every side, so that'll tell us how many sides it has. So 360 divided by 15 tells us there must be 24 sides. So the number of sides is 24. And there we go. On to our next question, we've got some SOHCAHTOA. Calculate the length of AB. Well, A to B is over here. I'll just label that X. Give your answer correct to 2 decimal places. Well, that side is opposite the angle in the question, so that's the opposite, and 16 is the hypotenuse. So write out SOHCAHTOA, and actually as soon as I've written my first one, I've got O and H. So if you use formula triangles, we'll make a formula triangle here. So for this one, we are finding the opposite, so if I cross off the opposite, it's S times H. So that is sine 38, your calculator will open up a bracket, so don't forget to close it, and then multiply by 16. We're going to type that into the calculator, so sine 38 multiplied by 16, and that gives me my answer, which is 9.85058. I'm going to stop there, because it does say give your answer to 2 decimal places, so chop it after that second decimal, and you get 9.85. That is in centimetres, it's got centimetres on the dotted line, so we just need to write 9.85, and that is our final answer. On to our next question. It says the densities of 2 different liquids A and B are in the ratio 19 to 22. The mass of 1 centimetre cubed of liquid B is 1.1 gram. 5 centimetre cubed of liquid A is mixed with 15 centimetre cubed of liquid B to make 20 centimetre cubed of liquid C. Work out the density of liquid C. Now whenever I have density questions like this, and I use the same method as when I'm working with speed, distance, time, and there's mixtures of journeys, I always draw a two-way table, just to categorise all this information, make it nice and easy to figure out what I've got and what I'm missing. So over here we've got density, mass and volume, we've got liquid A, liquid B and liquid C. And the formula for density is mass over volume, or you can use the formula triangle, density is equal to mass over volume. So let's put in the information that we've got. We've got the mass of 1 centimetre cubed of liquid B is 1.1. So 1.1 is the mass for 1 centimetre cubed. However, it does say in the question just here that 5 centimetre cubed of liquid A is mixed with 15 centimetre cubed of liquid B. So if that's the mass of 1 centimetre cubed, we're going to want to multiply that by 15 times 1.1, so that we actually have the mass of what we've used for liquid B. So 15 times 1.1 gives me a mass of 16.5. So that's going to be 16.5 grams. So let's get rid of that from the table. That's going to be 16.5 for the grams there. And we used a volume of 15 centimetres cubed. That's quite an interesting one because that actually told us what the density is. If 1 centimetre cubed is 1.1 gram, then that's 1.1 per centimetre cubed, or 1.1 gram per centimetre cubed. So that's actually the density, so 1.1. So we've also got one of our columns filled in. Looking at the next bit, we have 5 centimetre cubed of liquid A was mixed in, so we know that the volume of liquid A was 5 centimetre cubed, and of course it's told us the total, but we could have added those up if we weren't sure. It says work out the density of liquid C. So we're trying to work out this box just here. Now to get the density of C, we're going to need to know exactly what their mass is. So let's go back to this first line. It says the densities of two different liquids are in the ratio 19 to 22, and that's liquids A and liquids B. So here we've actually been given one of those densities. So A to B, it says it's in the ratio 19 to 22. And it tells us that the density of liquid B is 1.1. So we just need to figure out how we got from here to here and do the same to the 19. So we can do that. We can do 1.1 divided by 22, and that comes out as 0.05. So we've had to multiply by 0.05 to get to 1.1. We do the same to the left, so times 0.05. So multiply that by 19, and that tells us 0.95 is the density of liquid A. So 0.95 is the density of A, and now we can actually work out the mass of A. When we're working out mass, looking at our formula triangle, if you cover up the M, is density multiplied by volume. So for this one here, we would do 5 multiplied by 0.95, and that comes out as 4.75. We now have the mass of A and the mass of B. Together they will make the mass of C. So if we add those two together, 16.5 plus 4.75, that comes out as 21.25. We now have all the information that we need to work out the density of C. Density is equal to mass divided by volume. The mass is 21.25. The volume is 20. So 21.25 divided by 20 gives us 1.0625. No more decimals. It doesn't ask us to round it. So 1.0625 would be my final answer, and that would be my density. That was quite a tricky question because there was a ratio involved in there as well. But once we line them up using the ratio method that I've put to the side there, you can see it was relatively easy to see how they've got from 22 to 1.1 by just doing 1.1 divided by 22. That gave us the other density that we needed, but of course a question might actually just give you those densities. But there you go, that added something a little bit more tricky into the question. On to question 30, and this is our last question. We've got a simultaneous equation. There are two different methods really for simultaneous equations, and I tend to use the method where I make the coefficients of y the same. So in this question, I'm going to have to multiply the top equation by 5, and then both of those coefficients of y will have a 5 in front of them, one being positive and one being negative. So if I multiply that first equation by 5, I get 20x plus 5y is equal to 50. And I've multiplied everything by 5. The second equation I'm not going to change, so I'm just going to rewrite that as it already has that 5 in front of it. Of course I might need to change both, but in this case I've just decided to go for the 1. Now when there are different signs, you add the equations together. If we had the same signs in front of the similar coefficients, well, then we would subtract, but here we have a plus and a minus in front of the 5. So if I add these two together, I get 21x, the plus 5 and the minus 5 cancel out, and that's equal to 63. That gives me a really nice equation to solve. I can divide by 21, and I get x is equal to 3. I can then substitute this back into any of these four equations that I've drawn above. Obviously 2 of them are the same, but I can substitute it back into any of those to find the value of y. I'm going to sub it back into this first equation. So 4 lots of 3 will be 12, plus y is equal to 10. Hopefully you can see by looking at that y will have to be a negative number. If we subtract 12 from both sides, we get y is equal to negative 2. And there we go, there's my x value, 3, and my y value is negative 2. So x is 3, and y is equal to negative 2, and that was our last question on this paper. Okay, and well done for making it to the end of the video. Obviously don't forget to check out all the videos that I have posted recently going over all of these topics so that you can actually make sure that you've covered absolutely everything. But hopefully that one was useful and helpful, and I will see you for the video the night before the exam.